All right, this is the second lesson of today, lesson number 29. So we've been talking about permutations, and now we are going to move on to something called combinations. So a combination is kind of like a permutation, except when we're dealing with combinations, order does not matter. So 1, 2, 3 is the same as 2, 3, 1. As long as I have the same elements, the order does not matter in a combination. So if I am given n distinct objects, the number of ways to select R objects from the set is given by this equation. C of n and R is equal to, we read this as n choose R. We are choosing R objects from n objects. And it's given by the formula n factorial over R factorial times n minus R factorial. So let's do a couple of examples here. So given that there are 6 different flavors of ice cream at an ice cream parlor, how many different ways can I select 2 scoops of different flavors of ice cream? So in this example, it doesn't matter if I choose one flavor first and then the second flavor. The order does not matter. I just want to choose 2 flavors. So how many elements do I have? This is n. So I have n elements that I'm choosing from. And I want to choose 2 different kinds of ice cream. So I have C of 6, 2. We write this as 6 choose 2. I'm choosing 2 different flavors from 6. Is equal to 6 factorial over R factorial times n minus R, which is 4 factorial. Okay. So I have 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial is 2 times 1. 4 factorial is 4 times 3 times 2 times 1. I'm going to cancel out the 4, 3, 2, and 1. This gives me 30 over 2, which is equal to 15. So there are 15 different combinations of 2 flavors. I can pick from 6 flavors here. All right, and then what about Benjamin, who will choose 3 button-down shirts to pack for a business trip? If he has 12 shirts to choose from, how many different combinations of shirts are possible? So again, here order does not matter because we are just choosing 3 different shirts in no particular order from 12. So my n is equal to 12. I'm choosing from those 12, 3. So I have C of 12, 3 is equal to 12 choose 3, which is 12 factorial over R factorial is 3 factorial, and then n minus R factorial is 9 factorial. So I am left with 12 times 11 times 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. That's 12 factorial on the top. On the bottom, my 3 factorial is 3 times 2 times 1. My 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So I'm going to cancel out all of these terms. And I am left with 12 times 11 times 10 over 3 times 2 times 1 is 6. And actually, if I cancel out this 12 with this 6, I am left with a 2 on top. So I have 2 times 11 times 10, which is equal to 220. So there are 220 different ways to choose 3 shirts from 12 shirts. So this was a brief introduction to combinations. We'll be talking more about combinations this week. And that is it for today. So I will see you later. Have a wonderful day.